Good morning students, welcome back to your chemistry class. See, in your grade 10, today we are going to discuss about our first chapter, that is chemical reactions and equations. Okay, see, you know very well, you have 5 chapters in your 10th standard. In this, the first chapter is chemical reactions and equation. So, today we are going to discuss about this first chapter. Already in our online class we have discussed something. So here we are going to continue about this chemical reactions and equations. Okay. See, already in your grade 9 we have learned that what is meant by chemical reaction, isn't it? So what is meant by chemical reaction? It is nothing. It is the process in which new substance with the new properties are formed. See, during chemical reaction compulsory a new substance will be formed. That new substance is entirely different from its reactants, isn't it? For example, when magnesium ribbon burns with air to form magnesium oxide. See, this is one of the chemical reactions, already you know very well. When magnesium ribbon burnt in air, that is in presence of oxygen to form magnesium oxide. So this is one of the chemical reaction. During this chemical reaction, we have to know about the two part, that is first part is this is a reactant part and the another part this is product part. See, what is meant by reactant and what is meant by product? Already know very well what is meant by reactant. Reactants are nothing, the substance which take part in a chemical reaction. So what are the substances which take part in a chemical reaction are called reactant. And what is meant by product? See, the substance which gives a result is called product. The reactant combines together to form a new substance as a result. That result is considered as a product. So each and every chemical reaction you have to know about the reactant and product, isn't it? So in this chemical reactions and equations, now we are going to discuss about one by one. Listen carefully. See, this is one of the chemical reaction. I said to you, magnesium ribbon is burnt in presence of oxygen present in air to form magnesium oxide. So here now I will arise some question to you. See, how do we come to know that one chemical reaction has taken place? We are telling when magnesium burns in air to form magnesium oxide, here one chemical reaction takes place. So how do we come to know that one chemical reaction has taken place or not? How do we come to know that? That is with the help of some characteristics. With the help of some characteristics. So what are the characteristics of chemical reactions? Already we have discussed. That is, we have many characteristics already we have discussed. In that, first we have discussed about what is the evolution of gas. Evolution of gas. And then what is mean by evolution? That is during chemical reaction, the releasing of gas takes place. That is called evolution. So evolution of gas and then formation of precipitate. Formation of precipitate. Formation of precipitate and change in color. What we have discussed? Change in color as well as change in temperature. Change in temperature. So change in color as well as change in temperature. And finally we have discussed about what is that means. It is change in state. What is that? Change in state. So those things already we have discussed, isn't it? So how do we come to know that one chemical reaction has taken place or not? Means with the help of characteristics of chemical reactions. So what are the characteristics already we have discussed? That is evolution of gas. What is meant by evolution? You have to know that what is meant by evolution of gas. See, during chemical reaction, evolution of gas takes place. That is, evolution means that is releasing of gas. For example, I will tell you, that is when zinc granules reacts with any acid like sulfuric acid or hydrochloric acid. If you will take dilute sulfuric acid or hydrochloric acid, if you will add a small zinc granule and both react to form zinc sulfate, and during this process it releases hydrogen gas. During this process it releases hydrogen gas. This example during our online class we have discussed with the help of zinc granules and sulfuric acid that evolution of gas takes place, isn't it? Do you remember? So this is one of the example for what means it is characteristics of chemical reaction. What characteristics, with the help of what characteristics we can identify one chemical reaction has taken place or not, means here it is with the help of evolution of gas. What gas is evolved here? The evolution of gas is hydrogen. Here the evolution of gas is hydrogen. So how will you know that the releasing gas is hydrogen means? For that also we have discussed already. That means during this evolution of gas we have to keep one burning matchstick or burning candle near the mouth of test tube. It gives just pop sound. It gives pop sound. So with the help of that pop sound we can identify the releasing gas is hydrogen. So with the help of the evolution of gas we can identify one chemical reaction has taken place. So this is one of the characteristics of chemical reaction. Same like this, we have discussed already about the formation of precipitate. What does mean by precipitate? You know very well, the insoluble substance present in a solution. The insoluble substance present in a solution is called precipitate. This precipitate is a solid product, isn't it? Precipitate is a solid product. So, with the help of formation of precipitate also, we can identify one chemical reaction has taken place or not. So, for this, let us give an example. That is, how you identify? See, how you identify with the help of one more example. That is, we have discussed already. That is for formation of precipitate. What example that is? Lead. That is Pb. Lead nitrate, PbNO3 twice, and potassium iodide. See, both salts are colorless. This also during that online class we have discussed. That is lead nitrate also colorless salt, potassium iodide also colorless salt, isn't it? See, both we have to make a salt solution. See, before this reaction both also colorless, but after mixing these two, both also combine to form, that is lead iodide, and it form potassium nitrate. Lead iodide and it form potassium nitrate. During this process both react to form this lead iodide. This we are getting in the form of precipitate. That is, the color of precipitate is yellow. What's the color of precipitate we are getting during this reaction? That is, we are getting yellow precipitate. We are getting yellow precipitate. So from this yellow precipitate we can identify here also one chemical reaction has taken place. And some more examples also we have discussed for evolution of gas. For evolution of gas, instead of hydrogen, we have discussed about the releasing of carbon dioxide gas. That means, how will you identify carbon dioxide gas? We have lime water test. When we will pass carbon dioxide through lime water, it gives milky white precipitate of calcium carbonate. So that also the formation of precipitate we can take it as one example. And we have discussed about some more example. That means, what are the examples we have discussed? What's the color of potassium permanganate? It is purple color. What's the color of potassium permanganate? It is, the color is purple. What's the color of potassium permanganate? The color is purple. And what's the color of potassium dichromate? K2Cr2O7. It is orange color. The color of potassium permanganate is purple and potassium dichromate is orange color. Okay. And see here, this potassium permanganate. With this potassium permanganate, if we will add citric acid, the purple color changes into colorless. So the purple color changes into colorless. As well as the potassium dichromate is orange in color. See, if we will take this potassium dichromate. When we will pass sulfur dioxide through this potassium dichromate, it changes into orange to green color. So by this change in color, we can identify one chemical reaction has taken place. So this is also one of the characteristics of chemical reaction, that means change in color. What's the characteristics we have discussed here? That is change in color. Same like this we have discussed far, that is change in temperature also. The same example we can discuss for, that is zinc granules reacts with sulfuric acid to form zinc sulfate and hydrogen. During that process also, if we will touch the test tube, we feel hot. So in that place, the rise in temperature takes place. The rise in temperature takes place. So with the help of rise in temperature or fall in temperature, we can identify a chemical reaction has taken place or not. Same like this change in state. For change in state, we can take any example. A simple example, that is melting of candle wax, that is burning of candle wax. That is during burning of candle wax, what happens when we are burning candle wax? Slowly the wax burn to produce a liquid like substance, that is water. So wax is a solid, it is converted into water. So the solid substance changes into liquid state. As well as during this process, it releases carbon dioxide. So that carbon dioxide is in gaseous state. So change in state takes place. Okay. So like this, with the help of characteristics, we can identify one chemical reaction has taken place or not. Okay. Now we are going to discuss about what's that? Already we know very well, that is balanced chemical equation. Before going into that balanced chemical equation, we have to note that what is mean by chemical equation. See, we know very well about chemical symbols and formulas, isn't it? In your 9th standard, we have learned that what is mean by chemical symbol. What is mean by chemical symbol? It's a short way of representing an element, isn't it? For example, if hydrogen, it is represented with the help of capital letter H from its first letter, that is hydrogen. The first letter of this hydrogen is H. So the symbol of hydrogen is H. You know that. And same like this helium, already first letter H is used for hydrogen. So now here we will use this first two letter. First letter is capital letter and second letter is small letter, that is He. This is the symbol of helium. Same like this, some symbols we can derive from its Latin name. For example, what is that? Sodium. Sodium, the symbol is Na, because the Latin name of sodium is natrium. So we can choose this Na from Latin name. So like this, the symbol is nothing. It is a short way of representing an element. Same like this, we know about chemical symbols. Same like this, how you represent the chemical compounds or molecules means with the help of what? Chemical formula. What is meant by chemical formula? This is the short way of representing a chemical. It is a short way of representing a compound or molecule. This is short way of representing a compound or molecule. So this is called chemical formula. But here, with the help of the symbols and formulas, we are going to write a chemical reaction in the way of short form, that is called chemical equation. So what is chemical equation? It is a short way of representing chemical reactions. Chemical equations, listen, chemical equations are nothing, short way of representing chemical reactions by using symbols and formulas. For example, if I am giving one word equation, that means when zinc granules reacts with dilute sulfuric acid to form zinc sulfate to form zinc sulfate and hydrogen to form zinc sulfate and hydrogen. See, this is one of the chemical reaction. So, now we need to write this chemical reaction in the form of a short way by using symbols and formulas. Before this, first you have to note it with the help of word equation. How do you write with the help of word equation? First you have to know here it is zinc granules are given. So how do you write this zinc granules means that is zinc reacts with what's that? Sulfuric acid. Zinc reacts with sulfuric acid. Listen. Zinc granules reacts with sulfuric acid. So here zinc and sulfuric acid are reactants. So two reactants are there. We need to separate with the help of plus sign. And then next we are getting from this zinc sulfate and then hydrogen. So we need to separate these products with the help of plus sign. So this is one of the word equation. We need to simplify this with the help of symbols and formulas. That is called chemical equation. How do you simplify? That is zinc symbol is Zn. Sulfuric acid, the formula is H2SO4 gives, and what's the formula of zinc sulfate? ZnSO4 and hydrogen H2. Because you know very well this hydrogen, nitrogen, oxygen, chlorine, bromine, iodine, fluorine, these we need to represent in equation in the form of diatomic molecules, isn't it? Already we have learned about this in your 9th standard. So hydrogen, the symbol is H, but in equation you have to mention it as H2. Okay, is it right? Yes. So this is a chemical equation. So chemical equation is nothing. It is a short way of representing a chemical reaction by using symbols and formulas. This is called chemical equation. Okay. So now we have to know about the skeletal chemical equation, that is unbalanced chemical equation and balanced chemical equation. Do you know what is meant by unbalanced and balanced? See, balancing chemical and unbalancing chemical equation. Listen carefully. See, first we have to know about unbalanced chemical equation. Already you know very well, that is unbalanced means the equation is not itself, it is balanced. For example, when magnesium combines with oxygen to form magnesium oxide. See here, in this reaction, we have one magnesium on left side, one magnesium on right side, as well as two oxygen on left side, but one oxygen on right side. So this oxygen is not balanced, not equal in both sides. These type of reactions are called unbalanced equation. That means both sides the number of atoms are not equal. So how will you make this equation is balanced means by using a method like hit and trial method. See, first you have to know about why we need to balance a chemical equation. Why we should balance a chemical equation. Why we need to balance a chemical equation? Because to satisfy the law of conservation of mass. Because to satisfy the law of conservation of mass. What is meant by law of conservation of mass? Already we have learned in your 9th standard. That is, it is nothing. The mass of reactants must be equal to the mass of product. Why means? Because what is meant by law of conservation of mass? Mass can neither be created nor destroyed in a chemical reaction. So, total mass of the reactants must be equal to the total mass of the product. So, we need to balance a chemical equation. See, in your examination, they may ask one more question with the help of this equation. What is this? Why should a magnesium ribbon be cleaned before burning in air? See, because always this magnesium ribbon before using we need to clean with the help of sandpaper. Do you know why? Because the magnesium when we will left outside it readily combines with carbon dioxide present in air or oxygen present in air to form a protective layer like a basic magnesium carbonate layer or magnesium oxide layer. Magnesium oxide or basic magnesium carbonate layer. So it forms a protective layer like this. So to remove this layer we need to clean with the help of sandpaper. Then only this readily combines with air to form magnesium oxide. So keep this in your mind. Why should a magnesium ribbon be cleaned before burning into air means because when we will left outside the magnesium readily combines with oxygen present in air or carbon dioxide present in air to form a protective layer like magnesium oxide layer or a basic magnesium carbonate layer. A basic magnesium carbonate layer is made up of magnesium hydroxide as well as magnesium carbonate. So because of these protective layers we need to clean the magnesium ribbon before using, then only readily it will combines with air to form magnesium oxide. And then now come to this point. Why we need to balance a chemical equation? To satisfy the law of conservation of mass. So we need to balance a chemical equation. So how will you balance? By using heat and trial method. So keep one point in your mind. While balancing chemical equation, should not change any symbol or formulas. Only you need to add the coefficient in front of the symbols or in front of the formulas. Keep this in your mind. During balancing chemical equation, should not change the symbols or formulas. Only where you have to add the coefficient means only in front of the symbol or in front of the formulas only you need to add. So, how will you balance this equation? Check here. So, already we have checked this. Magnesium combines with oxygen to form magnesium oxide, and left side we have one magnesium, right side also we have one magnesium. So how will you balance? See, left hand side, right hand side, what is the magnesium? It is 1, and right side also magnesium 1, but left side oxygen it is 2. But right side oxygen it is 1. So first we need to balance the oxygen. So how you will change this 2 into here we have 2, here it is 1. So 1 into 2 we can make into 2. So you have to multiply this magnesium oxide by 2. So how will you multiply? See, 2 magnesium oxide is here. See, no need to add here because during balancing equation should not change the symbols and formulas. So you have to add in front of the magnesium oxide it is 2. So this is MgO, 2 MgO. Now check the equation. See how many magnesium in the left side? 1. But see right side we have 2 magnesium because this is both common for magnesium as well as oxygen. So here it is 2, here now it is 1. So now you have to balance this magnesium. So you should add 1 also, it is 1, and now you will try to add 2. So now also here 2 magnesium and 2 magnesium and 2 oxygen, 2 oxygen. Now the reaction is balanced. So like this you need to balance the chemical equation. This is already we have discussed. So keep this in your mind. While balancing chemical equation should not change any symbols or formulas. Only you need to add the coefficient in front of the symbols or in front of the formulas. Okay. So this type of equations are called balanced chemical equations. So you know very well what's the name of unbalanced chemical equation? That is unbalanced chemical equation, otherwise it is called skeletal chemical equation. Skeletal chemical equation. So you know this unbalanced chemical equation is always called skeletal chemical equation. Now here we are going to discuss about types of chemical reactions. Listen. Now, in this class, we are going to discuss about types of chemical reactions. So, listen. Before entering into this topic, you have to know about there is many types of chemical reactions are there. Here, in your 10th standard, only we are going to discuss about very few types. In this, now we are going to discuss about a few types of chemical reactions. What are the types of chemical reactions we are going to discuss means, listen, types of chemical reactions. In this, first we are going to discuss about combination reaction. Combination reaction. See, do you know what is meant by combination? See, the word itself you have answered. That is combination, combining of two or more reactants to form a single product is called combination. For example, we can use that when hydrogen combines with oxygen to form water. Listen here, hydrogen combines with oxygen to form water. During this process, see, the two reactants, hydrogen and oxygen, combine to form a single product, that is water. So, this type of reaction is example for combination reaction. Same like this, one more example I will give you, that is CaO, that is calcium oxide, combines with water to form calcium hydroxide. Calcium oxide combines with water to form calcium hydroxide. See, what's the another name of this calcium oxide means? It is lime or quicklime. What's the other name for calcium oxide? It is lime or quicklime. When this quicklime added with water to form calcium hydroxide, that is slaked lime. Calcium hydroxide, that is slaked lime. So, in your examination, they may ask one question, what happens when quicklime is added with water? When quicklime is added with water to form slaked lime. So, listen carefully once again. What happens when quicklime is added with water? When quicklime is added with water, it forms slaked lime. That is, quicklime is otherwise called, it is calcium. Chemical name of quicklime is calcium oxide. What's the chemical name of slaked lime? It is calcium hydroxide. So, a quicklime combines with water to form slaked lime. This is one of the example for combination reaction. And same like this, we can give many examples like when magnesium combines with oxygen to form magnesium oxide, and nitrogen combines with hydrogen to form ammonia. So these are some examples of combination reaction. So you need to balance these equations, balance yourself. Okay. So see what is combination? That is two or more reactants combine to form a single product is called combination. See, when hydrogen combines with oxygen to form water, or that is calcium oxide, quicklime reacts with water to form slaked lime, and magnesium combines with oxygen to form magnesium oxide, then nitrogen combines with hydrogen to form ammonia, carbon burns in air to form carbon dioxide. So these are some examples of combination reactions. Okay, see, and now we have discussed about, that is two or more reactants combined to form a single product is called combination. See, next we are going to discuss, that is what we have discussed here, that is quicklime combines with water to form slaked lime, isn't it? During this process, what happened means, the solution of this calcium hydroxide, that is slaked lime, is generally used for whitewashing walls. What happens during reaction? This reaction means, that is that calcium hydroxide, slaked lime, when we will apply on wall, it combines with carbon dioxide present in air and to form a white precipitate of calcium carbonate. and it form a white precipitate of calcium carbonate and form water. Listen carefully. Quicklime reacts with water to form slaked lime. A solution of this substance is generally used for whitewashing walls. How this reaction takes place means that slaked lime combines with carbon dioxide present in air. After 2 or 3 days after, it gives shiny finish to the walls because it forms a white precipitate of calcium carbonate during this process. Calcium carbonate during this process. Do you know, children? This is already we have learned, we have discussed for one of the tests for identification of carbon dioxide. Do you remember what is this carbon dioxide? What is this? Slaked lime or calcium hydroxide, or we will call it as an lime water. For all this same formula CaOH twice, calcium hydroxide, slaked lime or lime water. When we will pass this carbon dioxide through lime water, the lime water changes into milky white precipitate of calcium carbonate. Milky white precipitate of calcium carbonate. This is one of the identification test of carbon dioxide, already we have discussed. So same here we are going to discuss now, that is calcium oxide quicklime combines with water to form slaked lime. During this process, when we are applying the solution on wall, it reacts with carbon dioxide present in air and to form a milky white precipitate of calcium carbonate and water. So this gives shiny finish to the walls after 2 or 3 days. Okay, so these type of reactions now we have discussed about combination reaction. Next time we are going to discuss about decomposition reaction. See, decomposition reactions are opposite to that of combination reaction. Do you know what is meant by decompose? Listen. Okay children, listen. Do you know what is meant by decompose? See, if consider this is one leaf. If we are leaving this leaf into our atmosphere, what happens after 10 years or 20 years or 30 years back? That one single leaf will split into form that is many simpler substance, isn't it? That process we are calling it as a decomposition. Same like this, here also, now we are going to discuss about decomposition reaction. Here we are going to discuss about decomposition reaction. Do you know what is mean by decomposition reaction? That is same like how that single substance leaf after 10 years or 20 years, after 30 years back, it is split into form many simpler substance. It decomposes to form many simpler substance. Same like this here also, during chemical reaction, one single substance like for example calcium carbonate on heating gives calcium oxide and carbon dioxide. See here, during this process what happens? See, this is a single substance calcium carbonate, that is reacted. Decompose on heating to form calcium oxide and carbon dioxide. So how will you define with the help of this example? That means decomposition reaction is opposite to that of combination. What is combination? Two or more substance react to form a single product. But here what is decomposition? A single reactant splitting to form two or more substance. So combination and decomposition are totally opposite reaction. See, a single reactant decomposed to form two or more product is called decomposition. So these type of reactions are called decomposition reactions. During this decomposition reaction, we have different types of decomposition reaction takes place, like thermal decomposition. What is meant by thermal decomposition means? Thermal means what? Means it is heat. So decomposition reaction takes place in presence of heat. You know very well, that is while balancing chemical equation. Already we have discussed in your online classes, that is this del symbol indicates that heat, isn't it? Do you remember? This del symbol indicates heat. So on heating this calcium carbonate, it forms calcium oxide and carbon dioxide. So this reaction takes place, this decomposition reaction takes place in presence of heat. So this type of decomposition reaction is called, what is that? Thermal decomposition reaction. And next we have some more example, that is PbNO3 twice. On heating gives PbO, that is lead oxide, nitrogen dioxide and oxygen. See here, during this process, on heating this lead nitrate, it split into form lead oxide, nitrogen dioxide and oxygen. During this process also, the decomposition reaction takes place in presence of heat. So this is also one of the example of thermal decomposition. Okay, so this equation you need to balance. See, this is already, this equation is balanced. So this type of equation you know very well. This is self-balanced equation, so no need to balance. Okay, so this equation you need to balance. Balance yourself. And next one more example I will give you for this thermal decomposition reaction, that is on heating a green color salt, that is iron sulfate. On heating a green color salt, that is iron 2 sulfate, that is ferrous sulfate. On heating gives ferric oxide, sulfur dioxide and sulfur trioxide. So this also one of the example of thermal decomposition reaction, because the decomposition reaction takes place in presence of heat. Okay, so the decomposition reaction takes place in presence of heat. So this is also one of the example of thermal decomposition reaction. So you need to balance this equation also and see to this. See, in this decomposition reaction, calcium carbonate on heating gives calcium oxide and carbon dioxide. Lead nitrate on heating gives lead oxide, nitrogen dioxide and oxygen. And iron sulfate, that is ferrous sulfate, on heating gives ferric oxide, sulfur dioxide and sulfur trioxide. Or in all these processes, the decomposition, that means a single substance split into form two or more substance in presence of heat. So this decomposition is called, what that means? Thermal decomposition reaction. Okay, during this thermal decomposition reaction, and this nitrogen dioxide released to this process is a reddish brown gas. This gives a reddish brown gas. Same like this. Here, during this process, it releases sulfur dioxide and sulfur trioxide. Will get like sulfur smell. On heating this, it gives sulfur smell gases, that is sulfur dioxide and sulfur trioxide. So these are examples, some examples of thermal decomposition reaction. And as well as we have some more decomposition reaction, that is next type is, listen, photochemical decomposition reaction and electrical decomposition reaction. See, next, electrical decomposition reaction or electrolytic decomposition reaction. What is meant by electrical or electrolytic decomposition reaction? That means, listen carefully, during this electrolysis of water, what happens when water in presence of electricity, it gives hydrogen and oxygen. Listen, see, water in presence of electricity, it gives hydrogen and oxygen. This is electrolysis of water. What is this reaction? This reaction is electrolysis of water. And during this process, what happens means, we have to take water in a beaker and we need to set two rods. One is anode, another one is cathode. And during this process, we have to take a small amount of sulfuric acid, because this sulfuric acid makes water as a good conductor of electricity. And when we will pass electricity through this, on one side we will collect hydrogen gas and another side we will collect oxygen gas. See, which side we will collect hydrogen gas and which side we will collect oxygen gas, you know very well. Oxygen is negative ion, so positive rod side we will collect, and hydrogen is positive ion, so negative rod side we will collect this gases. So, during this electrolysis of water, what happens means water decomposes to form hydrogen and oxygen. So, this is one of the decomposition process. So, this type of decomposition reactions are called electrical decomposition or electrolytic decomposition. Electrical or electrolytic decomposition reaction. Okay, then one more example I will give you, that is NaCl, sodium chloride. In presence of electricity, it split into form sodium and chlorine. Sodium chloride in presence of electricity, it split into form sodium and chlorine. Same like this, one more example, aluminium oxide. In presence of electricity, it forms aluminium and oxygen. Aluminium and oxygen. So these are some example of electrolytic decomposition reaction, because a single substance decompose in presence of electricity to form two or more substance. So these are electrolytic decomposition reaction. Finally, now we are going to discuss about photochemical decomposition. What is meant by photo? Photo means nothing, light. What is meant by photo? Photo is nothing, it is light. Listen. Photochemical decomposition. Photochemical decomposition. So what is meant by photo means it is light. What is meant by photo? Light. So the decomposition reaction takes place in presence of light is called, it is photochemical decomposition. For example, that is silver chloride in presence of sunlight split into form silver and chlorine. Same like this, silver bromide in presence of sunlight split into form silver and bromine. See, listen carefully. Silver chloride in presence of sunlight split into form silver and chlorine. Same like this, silver bromide in presence of sunlight to split into form silver and bromine. In these two reactions, a single substance split into form two or more substances. So this is decomposition reaction. But this decomposition reaction takes place in presence of sunlight. So this is called photochemical decomposition reaction. Generally, during this process, we are using the silver chloride and silver bromide, generally used in black and white photography. Where we will use this? Generally, we will use this in black and white photography. So this type of decomposition reaction is called, what is this? Photochemical decomposition. So okay children, what we have discussed today, that is today we have discussed about what is chemical reaction. Already we have learned that, but we have recalled today that is it is nothing. It is a process in which new substances with new properties are formed. And how you identify the chemical reactions? With the help of characteristics. And what is chemical equation? Short way of representing chemical reactions by using symbols and formulas. And what is balanced and unbalanced chemical equation? We have discussed. That is, balanced chemical equation has both sides the number of atoms equal. Unbalanced chemical equation, both sides the number of atoms are unequal. Why should we need to balance a chemical equation? To satisfy the law of conservation of mass. Because according to law of conservation of mass, total mass of reactants must be equal to the total mass of product. So we need to balance a chemical equation. Because mass can neither be created nor destroyed in a chemical reaction. And same like this, we have discussed about types of chemical reaction. Today we have discussed two types of chemical reaction. One is combination, another one is decomposition. And both are opposite reactions. And decomposition reactions also we have discussed three types of decomposition, that is electrical decomposition, thermal decomposition and photochemical decomposition. So listen this and see to this. You have some examples are given here. It is unbalanced. Yourself you will balance while writing, and I will give you the worksheet. Complete it. Thank you children. Revise properly and come back.